So here we are at the water jet cutter, and I'm going to look at cutting out this engine mount bracket here. So I'm going to get set up and let's see how we go. So first up, we're going to run a test run with the abrasive disconnected, just to check that the water is pumping correctly. So to do that, I'll be opening the Protomax Make app. Got the water jet cutter turned on. You can see that it's popped up with a warning here that the machine needs to be homed. So I'll go ahead and click up here to home the machine, and you'll see that the head's going to move back to its home position. Okay, and now what I'm going to do is jog the machine into a location on the cutting bed where it hasn't been, where the cutting tool is not going to be directly over one of those slats, and I'll just do a quick test run without the abrasive connected. Okay, so I'm going to start with the Protomax layout software, and what we'll do is we'll import the Adobe file into here that's going to be cut out by the water jet cutter and create our toolpath. So I'm going to go here and I'm going to use this import from other CAD option. Okay, so there we have our two pieces to cut out. The motor mount flat plan as we designed in SolidWorks is here. Just checking the dimensions are correct here, because often with this program we might load up a DXF which is dimensioned in millimeters, but the program reads as inches, and we end up with an enormous job that we can't actually do on this machine. I'm just going to select all of the vectors. I'm going to create an auto toolpath. Once I've done that, just a case of clicking post. It asks us to pick a start location, which we'll make here. This gives us a preview of the toolpath, green being rapid and purple being a cutting, and then we save it. Now that that's saved, we can go on over to the Protomax Make. This is the layout again. We can go over to the Protomax Make. I'm going to open a new path. Okay, so now what we need to do is we need to place some material in the machine, home for the cutting to start at, which should be this point here. So I'm going to go and set up that machine now. Here's my piece of steel, 2 millimeters by 300 by 300, and I'll just push the Z axis up out of the way. This machine uses a spring lock mechanism to hold the material in place. And we're going to hand jog the machine into position where we want the cutting to start at. Got the splashback protector here in the way. It's easy to just turn that inside out. I just want to make sure that the Y-axis is and the X-axis isn't going to crash with that holder there. So I'll just run that past. Got plenty of clearance. Now, so go, no-go gauge here. If there's a gap in between, that's no-go. What we do is loosen the Z-axis control knob. Drop the Z-axis down so that the go, no-go gauge is up against the material. And that gives us our Z height automatically. No need to mess around. Alright, I'm going to close the lid now and let's see if we can't cut this material out. Just looking at the settings over here. We've got our thickness set at 3 millimeters. This material is 2 millimeters, so we'll be wasting a little bit of time there. So I'm just going to go and set that up as 2 millimeter thickness. And you can see the job time dropped from 16 minutes down to 12. It's a bit of a warning over here before you press begin. Make sure the nozzle's not going to collide. Ensure the path is cutting to the correct side of the line, etc, etc. Is the water turned on? There's no leaks. Is the abrasive hopper full? The feed tube is plugged in. That's something I haven't done yet since the test fire. So I'll just plug that back in. It's always good to follow a checklist. We've conducted a nozzle test without the abrasive. We've verified the material and the thickness is correct. The material is placed and secured. The splash guard is down. Yes. The nozzle standoff is at the height of the go, no-go gauge. We're ready to go. Just going to pause that here. It doesn't look like we're having a flow of abrasive, and you can see there the tube has gotten wet and the material's jammed up in the tube. So that's going to stop the machine from working. I'm going to go and sort that out now and then resume this job in a few moments. One nice thing about this machine and this software is the ability to back up. So rather than having to start a job all the way again, we can back up in the process. And we're going to back up to just before it tried to cut through there. And we're going to continue. While we're machining, we need to make sure that the abrasive material continues to get picked up by the hopper. You can see the feed mechanism here. It works on a vacuum principle. So I'm just going to give that a wriggle. over here on the computer we get real-time feedback of where the cutting tool was at. You can see the crosshairs here which indicate what the machine is up to, and we're coming along the last part of the cut for the first piece now. Soon after that we'll be onto the motor mount, which is the topic of this. Alright, so hopefully that means the machine is finished. Let's have a look. Now all that needs to happen is for that to be folded up into shape, and then we can test the fit on the actual car. Okay, so you can see the cobbled together original mounting system here. I'm just going to line up the new piece that I cut out today, and judging by that, looks like I've got the holes centered very well in the correct positions. So now what I'm going to do is go ahead and tap the threads. Now one thing about water jet cutting is that the outgoing water jet is wider than the ingoing water jet. So the holes will actually be slightly tapered, and that's because as the water and the abrasives passes through the material, it loses some of its energy. That water that you saw earlier was traveling through the material under a pressure of 30,000 psi, which is quite a lot. But it does lose energy, and the abrasive and the water scatters a little bit as it comes through, which causes that angular kind of cut. So the thread that I'm going to tap here is a M3. Going forwards about a turn and a half, maybe two, and then backwards a turn just to break the chips out. Now tapping through a piece of 2mm steel, it's quite easy. This is an open hole, so I don't need to use an intermediate or bottoming tap, just starting with the initial taper and driving the tap right through so that I know there's none of the taper left. And you can feel when the cutting is complete, the friction decreases dramatically. A bit more bow lube. It's important to keep the tap square as you are winding in the first couple of threads. That's the critical part. In order to make sure I get a radius on this bend, I'm going to place a piece of this copper here, and I'll do the vise up next to that. And to make sure I'm in the ballpark, I'm just going to use a vernier, 0.5 millimeter of gap from one side to the other. And that's a lot better. Alright, time to start smashing. Okay, perhaps not perfect, but I think it is time to align it up with the new motor and see how it looks. Okay, so now I'm going to remove the original cobbled together engine mount and see if the new one fits well. Now let's see how it fits in here. So I'll screw it in and see if it all seems to be working the way I want it to. Okay, and there we have it. The motor is now mounted nicely. There's plenty of room for adjustment, plenty of room for larger pinion gears if I want to make the top speed of this car even higher. It's currently 75 kilometers an hour. And if you caught my other video where we made a Python program to predict the pinion gear tooth ratio, if I want to hit 85 kilometers an hour instead of 75, I'll be needing to put a bigger pinion gear on here. So I've got plenty of room on the adjustments, as you can see, to slide the motor further forward. The only thing I'm a little concerned about, and it might be a little bit hard to see here, is that coming forward with the motor may need to check out some of this mounting system here just in order to be able to get around that shaft there. But we won't really know until we try.